Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is Lesson 9, Scientific Notation. So, here's an explanation here. It says a positive finite decimal. Finite. You might know the word infinite. Infinite means to go on forever and ever, not ending. So obviously finite, get rid of the in, and finite means ending, not going on forever. So a positive finite decimal s is said to be written in scientific notation if it is expressed as a product d times 10 to the power of n, where d is a finite decimal, so that d is greater than or equal to 1, but less than 10. In other words, d can equal 1, 2, 3, 4, 5, 6, 7, 8, or 9. And that is it. That's what this means. And if I put d here, then the number is, what they're talking about is the number in front of the decimal. So then the integer n is called the order of the magnitude. So this number here determines our order of the magnitude of the decimal. So in this exercise here, 17, the order of that scientific notation is 17. Okay, so all this means is I have a number d that can be any one of these. So if I just pick one, 6, that means that the number to the left of the decimal has to be one of these 9. And I can have any number back here as long as they end. They're finite. And then if I multiply that by 10, well, that would move my decimal one place to the right. So 6.435 times 10 would be 64.35. So I'm just going to do a few examples here. So let's just do this, and I'll put a 1 up here. 10 to the 1 is 10, and that tells me I'm going to move the decimal one place to the right, and that would equal 64.35. If I take that same number, 6.435, and I multiply it by 10 to the second power, then that is going to tell the reader to move the decimal 2 places to the right, and that's going to equal 643.5. And we continue doing this, so if I have 6.435 times 10 to the 5th, I'm going to skip now, then that is going to equal 1, 2, 3. So I have 6, 4, 3, 5, but I've only moved it 3 places now, and I need to move it 2 more because this was 5, so I need to add 2 zeros. So now it's 1, 2, 3, 4, 5, and the decimal ends up here, and 6.435 times 10 to the 5th is 643,500, because 10 to the 5th is 100,000. So 100,000 times 6 is 600,000. And that's what scientific notation does. It just takes really big numbers or really small numbers and represents them with scientific notation, so we don't have to sit here and write 17 zeros or 32 zeros. Okay, so now that we have the rules down, we have to keep in mind that d times 10 to the n is being observed. That's part of our answer. And we also need to make sure d is between 1 and 9 inclusive. Okay, so I'm going to start with this one. All this is saying is, are the following numbers written in scientific notation? If not, state the reason. So the first thing I'm going to do is I'm going to just write this every time so we can remember our rule. So the number's got to be greater than or equal to 1, but less than 10. And the number we're talking about is the number on the left of the decimal, and that is a 1. And since 1 is equal to 1, that's okay. So far so good. This is in scientific notation right here. The next thing is we need a multiplication symbol, we need a base 10, and we need an n that is finite. So we have an x, we have a base 10, and 17 is finite. So this is scientific notation. Exercise 2. Actually, I don't want to scroll too much. I want those rules to stay up there. Exercise 2. So the first thing I'm going to do is write 1 is less than or equal to, leave a space, is less than 10. I look at the number that's to the left of the decimal, and it's a 0. And 1 is not less than or equal to 0, so this is not true, so therefore this is not scientific notation. I have multiplication. I have a base 10 to a power of a finite number, but my number in front of the decimal is not 1 through 9. So that is no. It does say state the reason, but if I write this, I would believe that that is the reason. And then I would want to draw a line through here saying 1 is not less than or equal to 0. Okay. Exercise 3. Again, 1 less than or equal to, leave a space, less than 10. We're memorizing the rule here by repeating it in our process. Looking at the 7, I put the 7 there. And then ask yourself, is 7 greater than 1? And that's true, yes. And is 7 less than 10? Yes. So far, so good. Do I have a multiplication? Yes. Do I have a base 10? Yes. Do I have a finite decimal? Yes. So that is scientific. Exercise 4. Again, 1 less than or equal to, leave a space, less than 10. My number I'm looking at is 4. 4 goes here. 1 is less than or equal to 4, and 4 is less than 10, so that's okay. But right here I have a plus sign, and it has to be a multiplication, so this is not scientific notation. It should be 4.0701 times 10 to the 7, and that is the reason it is not scientific. Okay, exercise 5. Write the rule. 1 less than or equal to, leave a space, put a 10. Bring down the number that is to the left of the decimal, and 1 is less than or equal to 18, but 18 is not less than 10, so this is not scientific notation. The other reason, if I continue, there is multiplication, but 5 and base of 5 is also a reason why that would not be scientific notation. So 18 is more than 9, and the base was not 10. 2 reasons in that one. And then finally the last one. 1 less than or equal to, leave a space, less than 10. The number we're looking at here is 8. 8 is the same as 8.0. So if I'm looking at the number to the left of the decimal with a whole number 8, it is just 8. It is okay to write that without a decimal. 1 is less than 8, and 8 is less than 10, so that's okay. I have a multiplication symbol, I have a base 10, and I have a negative exponent, but that's okay because it is finite. And the answer to this is yes. So 1, 3, and 6 were, 2, 4, and 5 were not. Okay. Use the table below to complete exercises 7 and 8. The table below shows the debt of the 3 most populous states and the 3 least populous states. So exercise 7 says, what is the sum of the debts of the 3 most populous states? Express your answer in scientific notation. Now there's 2 ways to do this, and I'm going to do both ways the first time, but I'm only going to do one of the 2 ways from there forward. So they want to know the sum of debts of most populous states, and these are the most populous states at the top. So the 3 most populous states are California, New York, and Texas. Okay, so they want us to add those up. So one way I can do this is 407, and there are 9 zeros. So if I just copy these down, and then it's 337, and then 276. And if I add these up like this, obviously we're going to 0 plus 0 plus 0. We're going to keep getting all these zeros here. And then 7 and 7 is 14, plus 6 is 20, carry the 2. 2 plus 3 is 5, plus 7 is 12, carry the 1. 4, 5, 6, 7, 8, 9, 10. So I get 1,020, and then a bunch of zeros. Okay, so if I want to express that in scientific notation, I would put 1 0.02, and then you stop there because the rest are zeros. And then if I have the decimal here, then I got to move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 spaces. So this is going to end up being 1.02 times 10 to the 12th power. That is the sum of the most populous states. Okay, so now we're going to do that a different way, and I'm going to do the scientific notation first. So the first thing I'm going to do is write 4.07 times 10, and if the decimal was here, that'd be 1, 2, and then the 9 zeros would make a total of 11, so that's going to be 10 to the 11th. So it's 4.07 times 10 to the 11th power. So if I do that, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 puts the decimal after the 4 before the 0. So it's 4.07 times 10 to the 11th. 337 would be 3. Remember, my number before the decimal has got to be between 1 and 9 inclusive. I'm going to put 3.37 times 10 to some power. And these are the same size numbers, same number of digits, so it's going to be 11 again. And then finally 276. Again, the number in front of the decimal has to be between 1 and 9 inclusive. So 2 is greater than 1 and less than 10, so I'll put 2 there. 0.76 times 10 to the 11th power. And when I add all these up, when we're adding all these, when we're adding zeros, we're just bringing them down here. So just like here, 0 plus 0 plus 0 is 0. So if I add 11 zeros across 3 times, 0 plus 0 plus 0, I'm just writing 11 zeros. So this doesn't change. You do not add the exponents when adding. That's when we multiply, the exponents get added. When we divide exponents, they get subtracted. We don't have a rule for exponents when adding powers. They stay the same. So it's going to end up being 10 to the 11th power. That does not change. We're still going to have 11 decimal places. Okay, so now we have to add these. 7 plus 7 is 14, plus 6 is 20. Bring the 2 over. 2 plus 3 is 5. And then another 7 is 12. Almost forgot that last 7. So that's 12. Carry the 1. And we have 5, 6, 7, 8, 9, 10. And we have 10.20 times 10 to the 11th. That's not the same thing I got here, but we have a problem. 10 is not less than 10. So I need to move my decimal one place to the left to finish this. So this is 1.02 times 10 to the 1 more decimal place than where it was, 12. Okay? And then B. What is the sum, I shouldn't scroll too far, what is the sum of the debt for the 3 least populous states? So sum of debt for the 3 least populous states is right here. So I'm going to do it with the scientific notation way so we get used to moving a decimal after if we have to. So that's how I'm going to do this from now on. So this number has 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it'd take 9 moves to put the decimal right here after the 4. So that is going to be 4.0 times 10 to the 9th power. And they're all the same digits, so I'm just going to rewrite that. 4.0 times 10 to the 9. And then the last one is 2.0 times 10 to the 9th. Now that I have those values, I'll work with these. When I add, 10 to the 9th does not change when we're adding. And the 0 plus 0 plus 0 is 0. 4 plus 4 is 8, plus 2 is 10. Okay, but now we have this issue where we have a number that's more than 9. It can't be 10, it has to be less than 10. So this decimal has to get moved one more space, and my answer is going to be 1.0 times 10. And since we move the decimal one more digit, we have to make this 10. We're adding a digit to our number. The number's getting bigger, so it's 10 to the 10th. C, how much larger is the combined debt of the 3 most populous states than that of the three least populous states. Express your answer in scientific notation. So it says how much larger is the combined debt. So how much larger? So if we have a total, or let's just say we have, well, what are we combining? The most populous states, and then we have the least populous states, and they said how much larger is this? Well, we're going to subtract to see what their difference is. It's a difference problem. So when I go back, I'm just going to use my scientific notation answers, which is 1.02 times 10 to the 12. So I'm going to write 1.02 times 10 to the 12th power. And then I'm going to take the least populous, 1.0 times 10 to the 10th. So that's going to be minus 1.0, and I'm going to add another 0 so we have the same number of digits here, times 10 to the 10th. I want to just make sure that was a 10. I think it was. Yes, 10 to the 10th. Okay, so now I want to subtract these. But we can't, because our base 10 to the power, if we're going to subtract, we can't add or subtract unless they're like terms, and these are not like terms. So I need a 12 here, or I could make this a 10 here, either way. So I'm just going to explain this in more detail. If I have 1.00 times 10 to the 10th, that means I'm going to move the decimal. So let me move this here. If I have 1.00 and I want to do 10, I'll move it up here, times 10 to the 10th. That means move the decimal 10 places to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And if I put the decimal here now instead of here, then it's 1, 2, 3, 1, 2, 3, and then let me get rid of my little counter, and 1, 2, 3. So that decimal's not there anymore. It is 10 billion. So 10 to the 10th is 10 billion. But if I wanted that to be to the 12th power, then how could I represent that? Okay, so we have this big number here, which is 1 times 10 to the 10. Well, if I want to represent this as a 10 to the 12th power to match this one, now I can go backward and say, well, 1, 2, 3, 4, 5, 6, 7, 8, 9, there's my 10, 11, 12, then I'd want my decimal here. So if I move the decimal 2 places to the left, I can rewrite all of this. So I'll say 1.02 times 10 to the 12th, didn't change, that's here. And now I'm going to subtract 0.01, 0.01 times 10, that's supposed to be a 12, to the 12th power. So all I did was move this 2 decimal places this way, and when I move it that way, I'm getting further from where I was, and that was able to make me change that to add 2 to that. So if I'm moving left 2, I'm going to add 2 to this. And now I have 2 numbers, and I have a 10 to the 12th power, same base, so I multiply that, and it just moves my numbers I'm lining up to subtract. So now I have 2 minus 1, which is 1, 0 minus 0, which is 0, and 1 minus 0, which is 1, and the decimal is here. So my answer is 1.01 times 10 to the 12th power. Okay. Okay, now it says, what is the sum of the population of the 3 most populous states? Express your answer in scientific notation. Express. All right. Sum of the population, so we're adding. And drag there a little bit. We're adding sum of the population, 3 most populous states. So I'm going to go back to my table here, and I'm going to bring this table over so I don't have to keep switching pages. Okay, that's better. Now the data I'm using is on the same page I'm working, so I don't have to keep going back and forth. So it says, what is the sum of the population of the 3 most populous states? Most populous states, sum of the population would be over here. Make it scientific notation, so we have 1, 2, 3, 4, 5, 6, 7 to get the decimal between the 3 and the 8. So it's going to be 3.8 times 10 to the 7th. These are all the same number of digits, so we're going to have 10 to the 7th every time. Okay? and then it's 1.9 and 2.6. I'm going to add all of these. Let me just move these up so I have room to show my sum. And I'm going to add all of these. So when we add, our times 10 to the 7 does not change. 9 plus 8 is 17, plus 6 is 23, carry the 2. 3, 4, 5, 6, 7, 8. So it's 8.3 times 10 to the 7th power. What is the sum of the population of the least 3 populous states? Those are right here. So we have 1, 2, 3, 4, 5 positions to get it over to where we need it to be scientific. So it's 6.9 times 10 to the 5th times 10 to the 5th. These are all the same number of digits, so these are all going to be 10 to the 5th power. And we're going to have 6.26, and we're going to have 5.76. So now that I've done this, I see that I have 2 digits that go out to the 10th position, but this one, or 100th position, and this one only goes to the 10th. So I'm going to rewrite this as a 100th position number, just so that they line up properly. The decimals have to line up. So it's 6.9, and I'll just put a 0 there. That's okay. Now they're all lined up. So 0 plus 6 is 12. 9 plus 1 is 10, plus 2 is 12, plus 7 is 19. We carry the 1. And 6 plus 1 is 7, and 6 is 13, and 5 is 18. So it's 18.92 times 10 to the 5th power, but we have a problem. It is no longer scientific notation because 18 is more than 10. So I need to write this as 1.892 times 10. I move the decimal one more place, so I need to add one more to my exponent, and the answer is 10 to the 6th. C. It says approximately how many times greater is the total population of California, New York, and Texas? Total population, that's here, of these 3. So I'm talking about this value here. And Texas, and to the total population of North Carolina, or North Dakota, Vermont, and Wyoming. How many times greater? When we determine how many times greater, we take a number divided by another number to see what we had to multiply by to answer this question. So I'm just going to steal my answers from above so I don't have to rewrite it. So I'm going to have, it's not together. That's okay. So we have 8. We have the 3, 8.3. Okay, that's not working. I'll just write it. 8.3 times 10 to the 7. And then we're going to use 1.892 times 10 to the 6. So I need to have that same number of digits. Actually, no, I don't. I didn't need to erase that. So it is 8.3 times 10 to the 7. We're dividing to find out how many times greater one is than the other. And we're going to take 1.892 times 10 to the 6th. Okay, let me explain that too, how many times greater. If I had 8 and I had a 2, and I said how many times greater is 8 than 2, then to get that answer you would take the bigger number and divide by the smaller number and say it's 4. So you'd say, well, 2 times 4 is equal to 8. So 8 is 4 times greater than 2. So that's what we're doing here. How many times greater is one than the other? Then we're going to divide to find our answer. I will use my calculator for this number. Okay, so here's my calculator, and I'm going to take 8.3. Let's try a point instead of a 2. 8.3. And we're going to divide it by 1.892. Just focus on the number that we're multiplying by, the 10 to the power number. And I get, so what I'm really doing is I'm taking 8.3 divided by 1.892, and I'm multiplying it by 10 to the 7th divided by 10 to the 6th. That's what we're really doing. So my calculator said that that is 4.3 4.38689. So it's approximately 4.387. Let's go out 3 decimals. 4.387 times, and remember our rule, 10 to the 7 minus 6. I'm going to show it just to recall that. And that is going to yield 4.387 times 10 to the 1, which is just 10. And 4.387 times 10 moves the decimal one place to the right, so it's 43.9. And I'm going to give an approximation symbol. That's how many times greater. That means for every person in North Dakota, Vermont, and Wyoming, there are almost 44 people in California, New York, and Texas. 44 to 1 almost. Exercise 9. All planets revolve around the sun in an elliptical orbit. Elliptical means ellipse. Okay, an ellipse. This is a circle. Actually, let's make a circle. Okay, shape recognizing. So there's a circle. If I drew an ellipse, it looks like that. Okay, so this is a circle, and this is an ellipse. And that's what they mean by elliptical. So let's use this symbol here to answer this question. So what they're saying is Uranus, furthest distance from the sun. So we have the sun right here. And we have this planet orbiting around. So if the planet is here, then that's as close as it's ever going to get to the sun. And if it's way over here, that's the furthest it's going to ever get from the sun, as this gets moved around like this. It is orbiting this sun, okay? So when it's here, it's closest to the sun, and when it's here or over here, it's the furthest from the sun, and that's what we're doing here. All right, so that's the explanation as to what this question is saying. So now let's answer the question. It says the furthest distance from the sun is approximately 3.004 times 10 to the 9. So that's the furthest. So that is this distance, 3.004 times 10 to the 9th. Okay. And its closest distance, which is here, is 2.749 times 10 to the 9th. Using this information, what is the average distance? So we have two distances, and to find average, you add them and divide by 2. Okay, so I'm going to take 3.004 times 10 to the 9th. I'm going to add 2.749 times 10 to the 9th. When adding, I need to make sure these are the same, and they are. So I'm going to get times 10 to the 9th. And 4 plus 9 is 13. 4 plus 1 is 5. 7 plus 0 is 7. And 3 plus 2 is 5. So the total distance, furthest and shortest of this is 5.753 times 10 to the 9th. We aren't done yet. We now have to take that and divide it by 2. So 2 and 5.753. I'm just going to divide that number, and I'm not going to divide the base 10 to the 9th power. That's not going to change with our division. 2 goes into 5 twice. 2 times 2 is 4, and so on. 1, bring down the 7. 8 times 2 is 16. Bring down the 1 and the 5. And 7 times 2 is 14. And bring down the 1 and 3. And 6 times 2 is 12. Bring down the 1 and bring down a 0. And 2 will go into 10 5 times. So half of 5.7 is 2.8765 times 10 to the 9th power. So this is our answer. That is the average distance the planet is from the sun. Okay? That is the end of lesson 9. go do your problem set.